Good morning, everybody, and welcome to Thursday, April 30th. This is AP Statistics. Today we're going to go over the last two prompts, number 5 and 6 from the 2019 FRQs. Number 5 gave us information about warranties against cell phones' battery life. So the question was that this new battery has an average lifespan of 30 months with a standard deviation of 8 months, and they're charging $50 to warranty against a 2-year or sooner battery death. They also give us that it is normally distributed. So question A, we're trying to find for how many months we expect the bottom 25% of battery lives to fall. So in order to solve the problem and have some work to show for it, what we're going to try to do is find the z-score that correlates to the bottom 25% of the battery life. So bottom 25%, somewhere over here. I want to know what the z-score is for the bottom 25% so that I can then use the z-score formula to unfold it for the number of months we're looking for. Again, the more work you can show on an open-ended prompt, the more credit you're going to get. I know you could just use inverse norm for raw data, but this actually shows some math. So in order to do that, we are going to use inverse norm to find the z-score. We said it was normally distributed in the prompt, so that helps us. So the inverse norm area of 0.25, I'm going to use 0 and 1 for the mean and standard deviation. I know they gave you the numbers 30 and 8. Yes, you could use them, and you're going to get these the calculators shortcut to the answer. But again, we're trying to show some amount of work on paper as well. So that's a z-score of negative 0.6745. And that's the z-score right here, negative 0.6745. To show some math on paper, we're going to then use the z-score formula, where z equals x minus mu over sigma. And we're going to actually just do some algebra to demonstrate that we, too, understand how the math works here. Multiply both sides by 8, and you'll get negative 5.396 equals x minus 30. Add 30 to both sides, and you get 24.604 months. So I expect 25% of these batteries to die before 24.604 months. Now, since the warranty is a 24-month or sooner warranty, I expect 25% of cell phones to die within warranty. All right, part B. So we want to find the probability that 24 or more of the cell phones are going to die. No, the probability, of the phone dying within 24 months given 30 and 8. So we have to do a little bit more with our normal probability rules. So this time for part B, it's the probability of actually having to use the warranty. So using the warranty, all right, will only happen if we have our cell phone's battery die within 24 months. So really it's the probability of the battery lasting no more than 24 months. We were already given that mu is 30 and sigma is 8 under a normally distributed cell phone life, so we can use normal CDF. I would use this, but also explain this, okay? So we can use the inputs of 0, 24, 30, and 8 as our boundaries. Please understand, again, you could also have used the z-score we just found, but explain this, all right? In the write-up, we could say the area under the normal curve from 0 months to 24 months. Remember the previous one, I was actually 24.604, so it's not exactly 24. Use this instead. So the area under the curve from 0 months to 24 months with a center expected of 30 with an 8 standard deviation gives us an answer of 0.2266. So there's a 22.66% chance of having to use the warranty. Okay? So a person that buys that warranty for $50 has a 22.66% chance of having to use it. And of course, it saves the money if the battery dies before or while under warranty. Okay? And we have part C. What is the expected value, the expected gain to the company when they sell the warranty on the cell phone? So this is expected value. We have X, the two results, which are either the company makes $50 because the battery is just A-okay, or the company loses $150 because the person had to use the warranty. We already know the probability of using the warranty. We just found it is 0.2266. So that's the probability the company loses $150 because when the warranty is used, of course, it's a loss to the company. So the remainder, 0.7734, is the probability that the battery is fine, it outlives the 2 years, and the warranty money is theirs to keep. In order to find expected value, we multiply X times P of X. So there's a 38.67 result when you multiply the top two, and negative 33.99 when you multiply the bottom two. The sum of the XP of X column is the actual mean of the weighted distribution, which is the answer of $4.68. And in words, you would say that the company expects to have a gain of $4.68 per warranty sold. It's in their best interest to sell the warranty in this case, because even when it has to get used, they're still making a net profit on the average sale. And that's question number 5, which brings us to question number 6. As you already know from past discussions, questions number 6 on the AP exams are the largest ones. They're worth the most. They were worth like 1.875 times the other questions. So they're longer. Doesn't mean they're harder. It just means that they are more in depth. So we're going to go through it. Just as a quick note, here's my answer to number 6. All right, it's not short. I tried to write out exactly what we should do. So number 6 talks about a distribution of apartment rentals in a particular city as listed on a particular website. And option A, or section A, asked, for whom does this apply? So we have results here, but what population can we generalize these results to? Here's what I wrote. It generalizes to available one-bedroom apartments in this particular large city whose landlords are willing to publish rent on this particular website. It seems kind of specific, but that's the only population to whom it applies. It's possible that there is a host of landlords out there that rent one-bedroom apartments that don't want to use this website or don't want to publish their fees. Maybe they only do penthouses, so there's a huge high-end market. I don't know. So that's who this applies to. Be specific when asked a question like this. All right, it's not just apartments in the city. No, that's wrong. Part B. All right. So what might be a downside to using the mean in a case like this? You can clearly see from the distribution that it is obviously right skewed with potential outliers on the high end. We have to know at this point that skewness and outliers pull the mean towards them. So right skew means the mean is getting pulled higher, especially high outliers, pulling the mean higher. It may misrepresent the technical average cost of a one-bedroom apartment in this city. So the median is a better choice because it is resistant to skew. All right, C. How would she go about modeling a normal curve here? Well, here's what I wrote. Since the sample size is 50, it's sufficiently large sample for normalizing with the central limit theorem. Remember, the central limit theorem likes to have sample sizes of 30 or more for non-normal populations. But she would have to compute the median price from every possible sample of size 50 from this website. That is a huge job. It is arduous. It is something that a person would not be able to do. But that is what she or a computer program would have to do. Well, fortunately, there are computer programs to do this. So part D asked us where the bottom 5% or the top 95% apartment values would be based upon the output they give you, because the computer ran through every possible or a sampling of whatever it was going to do. And it counted them for you. All right, well, there's 15,000 samples having been taken here. And they broke down by the frequency with which the median falls within those ranges. Okay, cool. There's 15,000 samples. So the bottom 5% would be 5% of 15,000, which is 750. You're just going to count from the lowest price value, count the frequencies until we get to and go over 750. Looks like the 750th value falls within the $2,500 field. So the answer for D1 is $2,500. D2, top 95%, well, again, 95% of 15,000, 14,250. Much easier to count backwards than forwards on this one. So just count at the high end and see where the 750th number backwards is. And we get a value that's in the $2,950 field. So the top 95% marker is in the $2,950 a month median rent. And part E, they want to know the proportion of apartments that fall within and including those values. So you're just going to count how many fall within and including those bounds. Easier to count what's outside of those bounds and then subtract from 15,000. Turns out there are 408 apartments cheaper than 2,500, not including 2,500. And there are 188 apartments that are, or samples anyway, that were more expensive than 2,950, not including the 2,950. And that gives us 15,000 minus a total of 596. So 14,404 apartments out of 15,000 apartments fall within that band. And that's 96.03%. So 96.03% of the apartment median rentals are between those bounds of 2,500 and 2,950. Lastly, part F. How do we make this into a confidence interval? Well, easily. We are 96% confident, or 96.03% if you want to be picky, that the true median apartment rental in this large city that lists on this website will be between $2,500 and $2,950 a month. You could also have said, find the center, that's $2,725. So the median rental price was approximately $2,725 with a margin of error of $225, because that's just the center of the interval we just said and the distance to each end. Not that hard, but you have to read through it and understand what you're being asked. It might take a minute. You got to think back upon all the material we covered. I mean, this isn't just, one section's or one chapter's worth of content. And the question number 6 like this, it never is just one chapter or one section's worth of content. Even the other problems often included multiple concepts. All right, that was the entire 2019 FRQ section. Remember, this year, you're going to answer 2 questions, and you're done. So this is pretty good review. Now, what I'm going to submit with this video and the Google Classroom link will be the rubric, which is available online. And you can go through it and you can score yourself and you can see everything that we just talked about. Okay? The assignment is going to be posted as well. It is one of the FRAPPYs. I'm choosing Chapter 4's FRAPPY or alternate FRAPPY because that's the experimental design and that was kind of important and we need to review that. That'll be the homework for tonight. Have a wonderful day.